Let's talk about sampling. Our first definition is statistics. This is the study of procedures for collecting, describing, and drawing conclusions from information. Now, a very simple definition that encompasses a lot of different topics. The important part to remember about statistics is most of the time, the true power of statistics comes from being able to predict the future or predict what everybody is thinking or what a population believes or entails, so forth. Now, what do I mean by that? Well, it's real nice for us to study how much sales were from the previous year. Doesn't do us a whole lot of good. It's trivia at that point. But if you want to study the sales from the previous year and use that to tell something about the coming year, maybe you need to hire 10 new people and get them trained before you got the work starts coming in on various contracts. Maybe you can see a pattern. Maybe you need to cut back. You need to lay some people off. Maybe you need to build a new building. You got students coming in and you're seeing that you need a new dorm. So you're using it to tell something about the future. If you're just studying the past and that's all you're doing and you're not using that to change the future, then it doesn't do you much good. Maybe you're trying to figure out if an area wants, like, for example, a new casino. And you obviously can't talk to everybody in maybe a county, so you take a poll, take a sample, a study, and you find what those people believe, and you use them then to tell what the entire county believes. Now we got a population. This is the entire collection of individuals by which information is sought. And we got sample. Sample is a subset of a population containing the individuals that are actually observed. Now, population does not have to be something big. I mean, like you might say a population is the entire world, and then a sample would be taking a random sample of individuals from the world, see what they believe. It could be just a class. Your population might be defined as a statistics class. And maybe your sample would be you pick 5 students at random to see what they believe about something. So don't get in your idea that population has to be something huge. It's just whatever you're studying. Now, a simple random sample of size n. Sample chosen by a method in which each collection of n population items is equally likely to make up the sample. This is in a lottery. Sometimes that's hard to make sure every population item has an equal chance of being chose. For example, let's say I want to take a sample out of all the people who live in Wichita. Think about this. Does everybody in Wichita have an equal, Wichita, Kansas, does everybody in Wichita have an equal chance of being chose? Well, where do I get my information from? If I get it from the property tax rolls, then the only people I'm going to be able to get is people that own property. If I get it from the voting registration, well, the only people I'm going to be able to choose is people that are registered to vote. How about the person who lives under a bridge and is homeless? Do they have an equal chance of being chose? No, I don't even know they live under there. So, again, sometimes it's hard to make sure everybody has an equal chance of being chosen. Sometimes you have to compromise that and just say, well, okay, we're going to go with what we can. Sometimes by choosing, narrowing it down like that, you can really screw up your sample, your study. And they've done this in the past. Like if I chose only people who paid property tax, well, that would get some people, but think of the people who can't afford property. Well, am I going to get them? No, I won't. You know, all the people live in maybe rentals of whatever sort, whether that's an apartment or so forth. I don't even get them. Maybe the people who own property, but it's really living in a poverty-stricken area, maybe they don't have money for phones, or they're not going to respond back. So again, you know, sometimes you can really screw it up by narrowing it down. Now, if I got 50 items, for example, or 20 items, or 30, and I want to choose randomly from within there. I want to choose like 5 items, 2 items, 3 items, whatever. How we can generate random numbers on our calculator. First thing we have to understand is what a seed is. A seed is a number the calculator uses to get the random number generator started. And you feed it a seed. In this example, we give 3, and then we're going to store it in rand. And let me actually show this one. So go to my calculator. I'll do 3. The arrow you see right there, you see the STO button? If I click that, then that puts the arrow on there. And I want to store that in rand. And where rand is located is underneath the math. So if we push the math, left arrow over to PRB, you see the first one says rand. So I do enter on that, and then do enter again. It doesn't do anything exciting besides come back and tell us 3. That's the first part. That's what assigns the seed. Then I'll do random integer. So I'm going to do math, left arrow over to PRB, and random integer is our 5th one. So I can down arrow to it and press enter on it, like this, and then press enter, or I could simply just press the numbers in front of it to 5. Either way, it chooses it. And I want to choose a number between 1 and 20, so I do 1, 20. And specifically, I want to choose 4 numbers, so I'll do a comma 4. You can put a closing parentheses, though the closing parentheses is optional on TA3, TA4, and now press enter. And that'll give me 4 random numbers between 1 and 20. If I want 5 random numbers, I can do my rand int again. You can do second enter to bring up the previous entry, or you can simply press math, left arrow to PRB, choose 5 for rand int, and do 1, 20, 5. And then press enter. Okay, so we get this. Now I get these 5 numbers. If I do second enter again, press enter, it brings up those numbers. Okay, now your seed should be based upon like something like your clock or your watch. Like right now, mine says 40 after seconds in terms of seconds. So I can do a 40 and then do a store and put that in the rand. So I do math, left arrow to PRB, enter on rand, enter again. Okay. Now remember these 4 numbers right here. 5, 12, 14, 9. That was when we did a random, we seeded it with 3. I just seeded with 40. So let me do a rand int, do a math, do PRB, do 5 for rand int, and I'll do 1, 20, choose a number between 1 and 20, and specifically I'll do a comma 4. That means I'm choosing 4 numbers between 1 and 20. And press enter. Okay, now these are not the same numbers we got up above. But let's put 3 in for our seed again. So I'll do 3, and then I'll do my store, and then I'll do rand int. So I'll do math, left arrow to PRB, and rand. Press enter. Now I'll do a second enter, and then second enter again. This cycles through your history. And I got rand int 1, 20, 4. Now if I press enter, those numbers should look familiar. 5, 12, 14, 9. So if you enter the same number every time for your seed, you'll never get random numbers. You'll always get the same ones over and over. Okay. So key thing to remember here is when you're doing the seed, go off of like the seconds off of your watch. Now these numbers we get here, let's say I have 20 states and I want to pick 4 of them at random. Well, now that I got these, I can pull the 5th item from my list, the 12th item, the 14th item, and the 9th item. So that's how you'd use the random feature on your calculator. Okay. Sample of convenience. A sample is not drawn by a well-defined random method. And I got a note here. Sample of convenience may be acceptable if the sample represents population. Sample of convenience. I come into a statistics class and I pick 5 people at random out of that statistics class. And I want to use those to tell me what everybody in the college believes. Well, it's easy. I walked into the class and the students were there, so I could pretty easily come up with a sample. I didn't have to do random numbers of everybody in the college and then go talk to those 5, try to narrow them, find where they're at. It's convenient. Might be acceptable. The question is the sample of convenience I did, is it representative of the population? If my population is the entire college, well, that doesn't include everybody. Students that are going in statistics are different than students in other classes. So it really doesn't give us a very good representation. And even the hour of the day, if it's night or morning or so forth, might be a completely different student in terms of demographics. Now we got stratified sampling. Population is divided into homogeneous, similar groups called stratums, and then a simple random sample is drawn from each stratum. Example, we got Democrat and Republican. Say we have 100 that we're looking at, and 90 are Republicans and 10 are Democrats. If I choose random numbers from there, maybe all I'll get is Republicans, and that's not what I want. Maybe I want to know what Democrats believe also. Well, what I'll do is I'll split them up, take those 90, have their own little group, stratum, and Democrats will be in their own little group, and then I'll randomly pick from each group. And that makes sure that I get kind of a representation from both Democrat and Republican out of a population. A lot of different ways you can split up people in terms of that. Okay, systematic sampling. Population items are ordered, and every kth individual is selected. Usually the first one chose for the sample is done randomly. Maybe I'm going to talk to every fifth individual that comes out of a store. And to begin with, I use random numbers, and I'm going to start with the 8th person. So I start with the 8th person, then I'll talk to every 5th one after that. What are some advantages of this and disadvantages? Well, advantages, it's easy. Disadvantages, I have to know how many I'm dealing with to begin with to get a good feel for what my sample is going to be. If I stand outside of Walmart and talk to every 5th person that comes out of there, maybe my sample is going to be 500 people. Maybe that's not what I want. That's too many. Maybe if I want a sample of 20 and I talk to every 5th person coming out of Walmart, I'm going to very quickly get my sample, and that doesn't really represent the entire range of people that come in maybe in a morning's time or a complete day's time. So it gives me a skewed result in that regard. This works real well if you know how many you're going to deal with to begin with. Like if I know I got 100 that I'm going to choose from, and then I'm going to use this method to choose, every 10th item or something like that, then I have a pretty good idea what I'm going to end up with. Now, voluntary response sampling. Sample is done by the individuals volunteering, such as calling into a radio station. Well, this has many disadvantages. It's easy. You can almost say it's convenient, but it's not easy. Think of who calls into a radio station. Well, if you're talking about a controversial subject, then you'll get people very opinionated one way or the other. And you don't really get a true idea of maybe what the average person believes, but just the extreme edge. Maybe you get people who just want to hear themselves talk. So, it's not a very good sample when that's done. It's entertaining. Okay, let's take a look at identifying the type of sampling used. An instructor walks into a classroom and asks the students whether they are for or against making marijuana legal. Okay. We got voluntary response sampling. This is where people are calling a radio station. Systematic sampling, like every 5th item. We got stratified sampling, where we split them into groups. Sample of convenience. Well, I think what we're saying here. Instructor walks in a classroom, asks the students whether they're for or against making marijuana legal. It's convenient, isn't it? You got the students right there. You don't have to do much work. You just can ask them. And we're not really talking about how do they determine the random numbers and so forth. This implies right here you're talking to everybody in your class and you're using them as a sample for maybe the college. Now, I'm reading a lot into that. It doesn't say that, does it? When you're doing a sample, you need to clearly define what in the world you're studying and have it all spelled out. Okay, the instructor randomly picks the number 7 and randomly picks number 5. He then takes a sample of students coming out of the library, starting with the 7th student and every 5th one after that. Well, if I come up here, that's systematic sampling. That's where you talk to every kth individual, starting with whatever one you choose. Okay, administration splits students at a college into 2 groups, men and women, and randomly picks from within each group. Let's see, where's that at? We're splitting them up into similar groups. The men are grouped together, women are grouped together. That's stratified sampling. That's where you split them into men and women, then you randomly choose from each group. Another definition. Another two definitions. Statistic. This is a number that describes a sample. And a parameter is a number that describes a population. Maybe you're looking at the mean age. And if you're doing it based upon a sample, a survey, then it's called a statistic. If you're looking at the mean age for a population, then it's called a parameter. So sometimes it's not so easy to determine whether you're talking about a sample or a population. Let's take a look at this problem. It says determine whether the underlying value is a parameter or a statistic. Some of these problems I've made up myself, and by making them up, they're not the best problems. Now this says the average grade for a class of 25 students in elementary statistics was 83.2. You have to ask yourself, am I referring to a sample or a population? Nowhere do I say sample, nowhere do I say survey, so obviously I'm talking about a population here. So that 83.2 would be a parameter. Now this, same instructions. Determine if it's a parameter or statistic. In a survey of 12,000 high school students, 74% of respondents indicated that they cheated at least once on an exam in the past year. Well, right away, they say a survey. And that implies that they're using that to tell something about the population, which might be all high school students. Since we're talking about a survey, again, that's a sample. That refers to this as a statistic. In a survey, it was found that 10% of married people have had extramarital affairs in the past year. Again, we're referring to a survey, which means that that 10% is a statistic. And one last one. This is one, when I designed it, I had something particular in mind, and then I had a student point out to one semester the flaw in how I have it written. Okay, in a particular elementary statistics class, only 50% of guys wash their hands after using the bathroom. And as weird as it sounds, this is one of the reasons I don't like to shake hands. This is fairly accurate. Now, when I designed this problem, I was thinking, okay, here we got a population. I'm not talking about a sample. I'm talking about a survey. So since we're talking about population as a parameter, student came in one semester, and they said, would this not be a statistic? And I said, well, what do you mean? It doesn't say anything about a survey or sample. And this student pointed out, it says in a particular elementary statistics class, only 50% of guys wash their hands. The question is your stats class, is it full of all guys? Or are we actually looking at a subset? We're taking a sample of that statistics class. No, like I say, just looking at a piece of it. So again, it's kind of, I leave this problem here because it shows that when you're doing a study, that you need to be very clear. You need to do a lot of thinking about what you're studying and how you word things, because you may mean for it to be a certain way, but it actually flips over to the other direction because you worded it wrong, you approach the study wrong. So I like this problem from that regard.